First time, I hope that everything is okay and we will start the recording. I think okay. Welcome to AI Integration Working Group's first meeting. I am your host Arda Güçlü today, and I am very happy to see you all finally after the configurations approvals and setting up all things for this working group. I hope that the outcomes in this working group we will have will be very useful for the entire Kubernetes ecosystem. So before jumping to the agenda items, is there anyone who would like to do the opening speech for us?
I can go. Hey folks, thanks for joining this work group. So it's taken a while, but finally we have it started and going, and looking forward to working with you all to see what we can do in this space.
Thank you. And actually, there was an topic, but it is deferred to next week So I added this general topic actually to discuss at least in a free format in this our kickoff meeting. And so thanks to that, we will get to know each other better in our first meeting. And after that, we share our perspective in the current states of Kubernetes ecosystem as well as the AI space. So I'm just wondering your thoughts about what is your perspective from the point of MCP and Kubernetes integration? But before asking you, I think let me summarize my perspective. Currently, this evolving space requires some changes in not only in Kubernetes side, but also in, as you all know, that this protocol side to align better in terms of the authentication and naturally integration, etc. So I wonder your thoughts about this as well. Kunal?
So I guess it may be a good idea to check if folks are aware of MCP. Maybe do a show of hands if there's a general awareness of what the architecture looks like. Then maybe we can talk about what the requirements are from a Kubernetes perspective. What may be the best pattern? Like, is a CLI pattern better, or is having MCP tools like having kubectl as the way to interact with Kubernetes, or direct integration with the API?
I think I missed that part. Do you ask me?
Yeah. No, I'm just wondering, like, if it's worth doing a show of hands from the attendees, if they are familiar with MCP, or if folks want to like have an overview of MCP from someone to get us all on the same page, and we can take it from there.
Yeah, makes sense.
I mean, it never hurts to level the playing field, right? And assume that not everybody's on the same page, even if, there's variances amongst the people who are attending. So,
Yeah, absolutely. That makes sense. So I'm wondering, like, I don't know, Mark, we're gonna call on you. Did you wanna do like an overview of MCP?
Yeah, I can do the overview if you want. Yeah, for I mean, I guess that everyone is familiar now with AI and large language models and how they interact, how you can interact with them as a human. So usually you have like a chat interface or some kind of UI where you ask questions to the LLM and it basically replies to you. The idea is that I mean, many times that you ask it to perform a task and the LLM has the perfect knowledge on how to actually perform that task. So it will tell you, I don't know, maybe I want to buy the tickets to a concert, right? Or to a museum. And they will tell you, you have to visit this website and then enter your details, then press whatever button and enter your credit card details and so on. So the LLM has the complete knowledge about how to perform a task. However, it relies on the human, on yourself, to actually perform the grunt work, which is maybe entering the website and entering your details and so on. In order to be able to bypass this complete step and to allow the LLM to perform these tasks, we rely on functions and on the inference server being able to perform actions on behalf of this human. So eventually, every agent actually try to implement different functions. So if you are trying Perplexity or whatever, you will see or you will notice that it can actually search or browse the web because they have some embedded functions that the LLM is able to call. With MCP, the idea is that you actually make this specification or protocol, some sort of abstraction layer, in order to be able to implement servers that actually implement these functions and that then can actually be reused by different agents or MCP hosts chat interfaces as or whatever you want to call them. So actually, before ChatGPT or Perplexity or whatever client you were using had to implement the functions with MCP, it's up to the I mean, like as for example for Kubernetes, you can implement this MCP server and then whoever is compatible with MCP. I mean, if they have an MCP client, they can actually interact with your Kubernetes MCP server and perform the functions that you are exposing without having to actually re-implement them for each client. So, yeah, I don't know if this is more or less clear.
I think this is a nice summary of what Model Context Protocol provides to us actually. Thank you, Mark, for this. Is there any other comments or opinions?
I have one comment. Is the video lacking for me? Can you guys able to hear me?
Yes.
Yeah.
Yes.
Okay. So I have built 2 or 3 MCP for my personal uses and for for the POCs and all. So what I have understood while building all of this MCP and while reading through how this MCP protocol came in picture, is that each model require a different sort of programming. As in, when you try to establish a one task like fetching some details or anything sort of like that, you have to write something in some detail that model can understand, right? And each time you deal with a different model, you have to reprogram or redesign your LangChain or whatever that you're trying to code into in order to basically provide the context. And most of the time, context is the problem where we are in a place where we have to design all of this tooling. So in order to avoid this redundancy of repetitive process of creating new tooling, new function for each kind of models, we decided to have this standard protocol where we can um, create a certain function that can be used in each call without having to recreate a same function for a different models, so that each model can use the same common pattern to talk to each other. I think that gives us a common ground And now I think after MCP, now we have this, I think, the Google different protocol for talking to model to each other. The AGI, I think I'm forgetting the name. The AGI one, I think that's the name. Probably, yeah, A2A. Yeah, thanks. Yeah, the A2A one. This is what it's kind of doing to how we model can talk to each other, have a common language to talk to. I think that's my thoughts on it.
Thank you. I agree with this standardization makes our lives easier, and it works as an thanks to that, this can work any kind of model instead of relying on some customization or custom structures within embedded in the model. So relying on some protocol, whether it is model context protocol or agent to agent protocol, this gives us an ability to work against any kind of LLMs actually. Thank you.
I'm wondering, like, if folks on the call are up for raising what their interest is in their work group. Like, are they looking to use MCP, or are they looking at a higher level to see how MCP servers can run on Kubernetes and so on? So I'm just trying to figure out like what the interests are among the attendees, and then maybe we can dive into different topics as we go through the cards. So maybe I can go first since I raised this. So I'm interested mainly in two topics. So one is how do we establish best practices for MCP servers to integrate with Kubernetes? So there are several different areas to explore, like what should the API surface be? How do we ensure safety? How exactly, where exactly an MCP server runs, whether it runs locally on a cluster or it can target multiple Kubernetes clusters at the same time. One more area would be how do you authenticate to the MCP server? Like MCP specification lays out how an MCP host can authenticate with an MCP server, but it leaves the backend unspecified. Like how does the server authenticate with the backend? So in the case of Kubernetes, right, we need to figure out how it integrates with RBAC, how it integrates with, say, external OIDC. How do we ensure multi-tenancy? Like, can a single MCP server for Kubernetes work for multiple users, or it makes sense to spawn one for user? Other areas are how many requests per second can it handle? Should it scale up or down? So I think plenty of things to think about from a Kubernetes MCP best practices perspective. That's one aspect of it. The second is, assume you want to run MCP servers on a Kubernetes cluster. So what is the best pattern for that? Like, how do we manage the life cycle of running MCP servers on Kubernetes? Like, is there a CRD or an operator pattern that we can utilize to run them at scale? How do we life cycle them? Like the spec itself is moving very fast. The backend API may not be moving as fast. So how do we line up how MCP servers are versioned? How do we safely upgrade them? How do we connect them to LLMs, like either Cloud API or through LLMD API, for example, and so on. Okay.
Jakub?
Yeah. Um, Sorry, I'm very new to Zoom, so I'll be trying to figure out how to do the raise hand gesture. But I'm interested in a lot of the things that Mrunal mentioned. Scalability is something that we've been looking at. And by the way, I work for a company called Stacklock. I should have said that before. But scalability is one of the things that we've been looking at. There's things like a lot of the MCP servers out there in the wild are using STDIO as the transport, but that's very hard to scale. As example of one of the things that we've been thinking about is, does it even make sense to invest a lot into scaling STDIO servers, or should we just try to say that one of the best practices for running MCP servers on Kubernetes is you just use streaming HTTP or SSC. Runal already talked about the authentication. That's something that I'm also personally interested in. Exactly the thing that he mentioned with the MCP server authenticating to the backend, which, yeah, as you said, the spec doesn't talk about that. And one thing that I put into the agenda, but we maybe can discuss it next time, if this is more of an intro call, is having some sort of a registry for MCP servers that are available for the cluster. There's a lot of activity upstream, but there's still, it's not exactly codified how to transform that into something that you can consume as a Kubernetes cluster administrator. So TLDR, scalability, registry, authentication, authorization.
Just to add on to that as well, I'm with Jakub, work for Stacklock as well, and we're both working on MCP pretty much. And just to add on to what Jakub said, there's some interest from myself and I think others as well in Stacklock around runtime security of MCPs as well, particularly where you know a lot of MCP servers are built for SDIO, but when you go to a lot of them, they're not containerized. And when they are containerized, they're containerized to run as root, and there's a whole load of bad practices there, and they're not really meant for containers. At least the initial ones aren't built for that. And you know, it makes sense for local developments if they just kind of want to run something locally. But when you're running MCP servers in production, you know, containerization has been around for a while now. People know, they're familiar with it. They're kind of familiar with what it does, what it doesn't do. They've got a whole ecosystem of things set up around that would help them leverage MCP to fit into their current workflows. But yeah, I just thought I'd add on to that, the runtime security aspect.
Thank you. I totally share your concerns, scalability and registry, for example. But from the Kubernetes perspective, as a 6CLI co-chair for years, the most interesting part for me is the authentication, because we get used to relying on the RBAC in Kubernetes clusters. So if you configure your clusters and RBACs correctly, you can safely assume that it works. It still works in this AI integration space, but it still requires some additional functionality, because you need to authenticate. MCP server need to authenticate the requests. You cannot just simply rely on the RBACs. So it's an interesting topic for me as well, including the others. Janet?
Yes, I'm Janet. So I'm interested in various areas, including how to better deploy MCP servers, and then things like how do we handle the case when there's malicious server attacks? How do we protect users from that, or how can they reliably trust an MCP server. And then there are also challenges of how do we discover MCP servers reliably? Is this a problem that can be solved by Kubernetes? Or is it something that outside of Kubernetes, perhaps we can also figure that out?
Jared, by discovering, do you mean like figuring out the endpoints where they are running, or
Yes.
what capabilities they have?
Yeah, figuring out the endpoints. What are the servers available for me to use?
Oh, okay.
Does this mean any MCP server running in the cluster, or the MCP server that is specifically running for interacting with the cluster? I mean, does this include the application-specific MCP servers running in the cluster?
It could be running in the cluster, or maybe there's a central way for us to host that discovery endpoint.
Yeah, that's a really interesting question. If you should, and sorry if I'm skipping ahead, but I also think this is interesting. If you have like an agent AI workload running in the cluster, should it be even allowed to see all the MCP servers that it can potentially connect to? And if yes, should it maybe be allowed to even to just see or use a subset of the MCP server functionality? So
Yeah. I
Thumbs up.
think maybe a question is like, can we lean on Kubernetes concepts like, okay, you can only connect to MCP servers in your own namespace? That could be one option, or there's an explicit policy for that. Some CRD saying what you can connect to. And I think other idea could be something like a catalog of endpoints like running on Kubernetes, and it could be like a front end for both the MCP endpoints running on the cluster or externally, and whatever is visible in the catalog, then you have some kind of access control for which workloads can connect to those endpoints.
I think this is the Kubernetes way, right? MCP servers will be running, represented as a CRDs with an add-on, some kind of access controls. Of course, people can build their MCP server images and running as a deployment. And in that case, they need to take care of some kind of all this heavy lifting themselves. But
Other challenge, right? Like servers could have like, there could be long running connections between the MCP host to an MCP server because of the nature of LLMs and what's going on. So you will also have to think about deployment patterns, like the rainbow deployment pattern, for example, for rolling out MCP servers, because you don't want to break existing sessions and connections. So that's another thing to worry about. And I think the MCP servers can be stateless or stateful with sessions. So can we do anything on the Kubernetes side to make it easy for MCP servers to store their sessions in databases or something? That could be another interesting area to explore.
I think we already discussed the discoverability of MCP servers as well. Seems like both of them. There are a lot of topics we need to take care, at least figure out in this space. Is there any comments or topics?
Yeah, I think on the discoverability thing, I think there's a lot of I think there's a lot of gaps in the spec. I think a lot of people realize that over time, and I think there's a real risk, or I think the chances of it happening is very high, whereby the gaps in the spec are made by companies who want to, sell a product or open source things, and all that kind of stuff. But things like discoverability, I'm always a bit. I don't know how I feel about that yet, because unless they build something in the spec that that handles that, that then tools can use to discover MCP servers, unless it's in the spec, I do feel that a lot of people will just end up writing, whatever kind of workloads in their cluster that go searching for workloads with a specific label, kind of like how Istio does with sidecars, or if there's a certain label attached to certain MCP workloads, then that's how discoverability works for a lot of cases. I do feel a lot will go in that direction, unless something happens in the spec where there's a standard around how MCP servers let themselves get discovered. I think there's going to be a lot of overlap in that space, and I kind of feel like the spec should, or at least the discussion should be coming from the spec. But I don't think that's going to. I don't think that's going to happen anytime soon. I think there's still some big holes in the spec around scalability and all that kind of stuff, which running on production is kind of what you care about.
It seems like discovery and the registry are some kind of interacting. For example, discovery works to find all the MCP server running in the cluster, but meanwhile registry is also needed to prevent any malicious MCP servers running in the cluster. And you are discovering the clusters, and maybe you can somehow check this, somehow scan this and cluster to detect any malicious ones running or not.
Yeah, the registry is an interesting one, because I think there's a lot of people who have different views on what the registry is. I think a lot of people, when they hear the word registry, they just automatically think of an OCI registry that just hosts a bunch of OCI artifacts like images and charts or whatever. The registry itself is more of a meta registry. It's information about MCP servers, not the MCP servers themselves. Although you ask some people, and they may even disagree on that point. But yeah, you're right. There's a lot of depending on who you ask, their view of what a registry would do is it would be aware of the MCP servers that are deployed, and it would kind of warn you to say, by the way, this has now got a new version, or this is now vulnerable, or it would hook up into any scanning capabilities that emerge from MCP land. But there's a lot of assumptions on the registry stuff at the moment. I know that we've got someone internally, Stacklock, that's working with the MCP folks on the registry itself, and you can see he's kind of very his brain is growing by the day just because of how much stuff is going on in that space. But yeah, I've shared that mention where the MCP the discoverability factor is built into the registry. I just wonder whether that's an upstream change or whether that's a change that kind of comes from a tool itself that then you kind of put into your cluster, and it's aware of those MCP servers. I do feel that there's going to be a lot of different types and different shapes and sizes of registries in the next in the next year or two.
Yeah, and definitely, I think it'll be useful to have like if someone more familiar with the registry can do a topic here in one of the upcoming calls. And I feel like there are too many registries, right? Registries I see is like open for all, because I don't know what a current number, highest number is. It was like 5,000 few months ago. Was it 10,000, 12,000? But so registry by default, you cannot assume that MCP servers are stable, secure, or ready for production. So like when you are trying to run something on your own cluster, you will have your own curated registry or a catalog, and maybe some work you have done to ensure that, okay, this is my list. of the 10,000 here, I only feel that these 100 are the ones that I want to allow my Kubernetes cluster users to use because they are safe by my standards.
Well, as registry, do we all mean that the containers, container files actually, right? So all the tools we have in the ecosystem can work on these MCP servers, or we are talking about something very different with the registry. Because when I talk about it, I always think about some container files running in an application, which actually points to an MCP server.
So I think the MCP registry, I mean, Yakub and Chris can correct me, is more like a metadata registry. It doesn't actually host your containers. It points to some other location like an OCI registry or S3 or some other blob storage where your actual content is hosted. It only points to that. So that's the distinction between OCI registry and MCP registry.
Yeah, exactly. It's a meta registry basically that points to it'll have information about MCP servers in the wild, and it'll have a URL that points to the actual artifact, which itself would live in a separate OCI registry, for example, Docker Hub or GitHub registry or whatever they are. I think the intention, or the model, I think that some people are following is that the upstream registry or the meta registry that's been worked on by the MCP folks, that will come out with a registry spec, and people will be kind of downstream from that. So they will have their own kind of version of a registry that will kind of comply with that, but also add other bits of detail to it. So for example, the meta registry may just have information about an MCP server, its description, its tool types, tool descriptions, you name it, version maybe, hopefully, and then the link or a URI where the actual image is, or the package is, if you're saying NPM. But it won't have information about security or provenance. So you can see a world where someone would come up with a registry product that is theirs, and they offer more checks in advance and say, well, out of the 1 million MCP servers that are on the meta registry, we've scanned all of them, and we've got a certain set of heuristics that we judge them by, and these are the ones that have passed that check. And it'll be big green ticks by provenance and security. There'll be big green ticks on security grading or however they do that. But I think that's kind of what will happen. It just depends on how fast things move, and it also happens. And I also think, depending on what decisions are made around the upstream registry and whether there's some glaring holes there, I think depends on whether it's actually effective.
Yeah, I think the other concern I have is like the upstream registry implementation isn't something like isn't intended to be run on your own infrastructure. It's only being written in a way so that it's hosted officially by someone. So I'm not clear on that. Like for example, like when Docker came out, Docker distribution was something that you can run and host your own registry on top of, right? So that's another fuzzy area.
Just quickly, Chris mentioned things like provenance, and Janet earlier mentioned being interested in how do I know if a server is safe to consume. I think from upstream perspective, they kind of are aiming to solve this through vendor extensions or extensions to the registry spec. Rado would know more about that because he works with upstream on registry. But maybe one thing that might be interesting for this working group is seeing which of the extensions, like pointing to provenance, are the most interesting or would be the most useful from Kubernetes operator perspective, and trying to work more with the MCP upstream in making them not extensions, but actually part of the standard.
Yeah, I was thinking of like we have Sigstore, right? Like that's something that feels like a no-brainer to me to check. Okay, something was signed, and we can prove who signed it. So at least if something goes wrong, we have a trail. I'm not sure if that's something that's been discussed in MCP upstream, but maybe worth pursuing.
Yeah, kind of relaying what I heard, so it's kind of playing a bit of game of telephone. But I think different people have different kind of incentives when it comes to the upstream registry. There are people who just want to have almost like you have these awesome lists on GitHub that contain just everything under the sun, and they want the registry to be kind of like this. And then on the other side, you have the more enterprisey deployments who want to have very restricted set of MCP servers that you're allowed to host or run. And yeah, the upstream spec is the impression I got it was that the upstream spec is kind of trying to serve everybody. And the way they are trying to serve everybody and please everybody is by using these vendor extensions.
Yeah, I think Chris, like containerization, I think is a no-brainer. I don't know if folks here would disagree, given that this is a Kubernetes work group.
Yeah.
Yeah.
You'd be surprised how rare they are in the wild with MCP. There's a lot of just run this Python on your via Claude and you'll be happy. And it's like, no. I won't be happy.
Yeah, that's something this work group can advocate for. Like MCP server should always include a Docker file / container file. So there's a standard way to build it. And then I think someone mentioned running as root. So how do we avoid that? Maybe recommendations on setting the right user and the right security context.
Yeah, there's quite a few that we've used that haven't got Docker files, so we've had to build our own tool to Dockerize them ourselves with best practices because there's so many out there that just don't do that. So yeah, it's things when you have a moment where we have to develop a tool to containerize a package, then it probably suggests that the underlying ways of working or kind of culture around MCP is lacking in the containerization aspect, as if you have to build tools to do that for you.
Yep, makes sense. Maybe this work group can have a stance on, okay, these are the recommended practices for packaging and running your servers securely.
Otherwise, sounds like a go backwards, because with the container files, we get the ability to run independent from the host, run applications independent from the host. But with respect to container files, now personally, I don't see any room for stdio in this ecosystem, Kubernetes ecosystem, I mean, because how are you going to run this? Port forwarding or etc. Or why do you need this? Or not?
So I think like the whole thing started with STDI, right? It was easy to just run experiment with quickly, and then the spec evolved to add the other transports. So I think in the MCP journey, some people may just be happy with their STDIO and don't want to deal with the complexity, and they can use a gateway or a proxy in front of it that converts your STDIO into a streamable HTTP. Something I would do, but not something I would rule out either, saying, oh, okay, I had this team, they have vibe coded like 50 STDIO containers, they don't want to deal with streamable HTTP. Is there a project that can just run it on Kubernetes with the right transport.
Yeah, I think it's the fact that the SDIO was obviously first, and it allows you to run it locally, or just using Python. But I also think it's because the clients themselves didn't support anything other than that. So we had a kind of a matrix table, compatibility table in Toolhive, and we realized that there was a bunch that just didn't support SSE. And I think there are some that still doesn't support SSE or streamable HTTP, and they're very, very popular. So it's kind of like, yeah, there's for some people who are authors of MCP servers, there's just no incentive for them in some cases because they just don't have clients that would use it. And then, yeah, until most clients use streamable HTTP or elsewhere, then it's I don't see many people dropping SDIO. And yeah, closed desktop is one of them. It's one of the most famous ones, and yet it still doesn't support anything other than SDIO, which is not great. But yeah, it's not good. I'm not a fan of SDIO at all. But yeah, unfortunately, it's I think here to stay for a bit longer.
Yeah, I mean, luckily now I think VS Code has become a much more fully fledged client. So there are options beyond Claude. I'm wondering if there is also interest on like MCP hosts, or like people expect mainly headless agents as their deployment patterns. And by that I mean like by that I mean like you have some web application, I think OpenWeb UI or similar, that can act as a MCP host, and you can potentially run it in a Kubernetes container, as opposed to running a local desktop client like VS Code or Claude or Goose.
We've had pretty good success with running LibraChat. It's open source. It moves quite fast, sometimes too fast. But they've been also quite open and friendly in accepting patches in case we needed to fix something, and it works fine on Kubernetes. And yeah, it's just like sample size of one, but for the record, we chose LibraChat exactly as Chris said earlier because we needed a client that supports something else than stdio, and we wanted to run it on Kubernetes.
No?
This was a very please go ahead.
No, sorry, late question. But are we thinking of a model where we would potentially have our own agent running on the cluster as well, which would interface with these MCP servers?
Yeah, pretty much, right? Like an agent needs an LLM API, which could be a Frontier API running in the cloud, or an API, say, provided by VLLM or LLMD running on the same cluster or different cluster. That's one part of it. And then agent has memory, and agent needs access to tools. But agents themselves are, for the most part, just regular processes, and they can run like containers directly on Kubernetes, like just like anything else. So I think that's a very valid use case, that agents are running on Kubernetes.
So the deployment model that we would probably advocate for is to have a Kubernetes cluster which acts as a agent / MCP server host,
A platform
which
for
can
running
connect
MCP
to other
server.
Kubernetes servers.
Yeah, depending on like how your LLM is hosted, right? Like you could have a special cluster for your LLM, and it provides an API endpoint, and your agents connect to it. Or it could all be on the same cluster if it's a small model just consuming a single GPU. That's another option. So various possibilities, but I think running MCP servers and agents on Kubernetes makes a lot of sense.
Yeah, it's also opens a whole other interesting avenue of discussion because the agents also need some kind of identity. And then the identity can be also used to authenticate to the MCP servers, either taking into account also who is using the agent or not. But that would be really long discussion on its own. And Kubernetes kind of makes sense even thinking about the most basic model of this deployment, because then if you run the agent as a Kubernetes workload, you can give the agent a service account, which is a JOT, and then you can use this JOT to make policy decisions. So yeah.
Yeah, I think that makes a lot of sense. And Spiffy Spire could also come into the picture depending on how the path flows will go. Sorry.
This identity is an interesting topic because currently model context protocol ecosystem, you just run the npx xMCP server and expect that this MCP server is running on your local machine. This is surprising me because there is no identity, etc. And I don't even know that I'm currently running correct MCP server. And this is more problematic in cluster side. So we need to kind of stamp with an identity all these MCP servers to ensure that we are talking about this MCP server.
So I'm working on a project called Agent Sandbox in SIGAPS with the other SIGAPS members. So basically, we are also trying to figure out how people can run agents on Kubernetes, and we're trying to create a new workflow API for running agents, and identity is part of the characteristics that we are figuring out. And one of the concepts we want to use in this project is that we want to leverage some of the runtimes that provides isolation so that you can run tools, agents can run tools in a safe environment. So that's the idea. So maybe we can collaborate on that for the agent, what the agent workload look like, and then how do people provide their own identity to the agent? How do they run the tools safely?
So I think, Janet, this looks awesome. This is the kind of thing I was hoping this work group could tackle. So are you open for like collaborating on this with the AI integration work group?
Yes, so this is a sub-project under SIGAPS, but anyone can just come and either contribute or file issues or review code.
Okay.
Gabi is one of our sponsors, so that
Yeah,
that's
exactly.
a good overlap.
Yeah, I think this has a lot of overlap with all the things we are trying to solve. So, yeah. So, Janet, is there like some slide deck or some presentation that we can do to go over what's been discussed for the agent sandbox so far? If you're open to it next week, I don't know.
Yeah, I can. I don't have slides yet. I only have a doc that discuss the concept, and then I copy the content of the doc to the README. So the README should have most of the information we want. I can also present next week. or in
Okay.
the next meeting.
Okay, sounds great. Yeah, would love to dive into this a bit deeper.
It sounds great. Thank you. Is there any other comments, opinions? We have 8 minutes.
I'm just curious, like Janet, if this also include the life cycle aspect of it. And I think next week we also have a topic of life cycle, and hoping that Yakub can show some things there, and then we can figure out how it intersects with Agent Sandbox.
Yes, this includes this life cycle as well. The goal is to make the orchestration of those pods easier so that users can just use simple API to do all the common patterns that they need for running an agent.
Okay. And is it like agnostic of the frameworks, or
Yeah,
like,
this is still very early. So we
okay.
try to make it agnostic of different container runtime. And then for framework, I think this is still under iteration. We can discuss how we want to solve that.
Okay, sounds good. Because we got some side chatter around the identity piece. Anything Yakub or someone wants to add?
Not related to that, but there was a bit of discussion about the registry, and it seemed like people are in general interested in what's going on in upstream. I was wondering if that would make sense to put as either next week or next to if
Yeah, I guess we can start lining up topics and then we go get to them in order, I guess. Yeah.
Just on the agent stuff, it's probably worth having 2 threads going on. Well, more than one thread, at least anyway, regarding MCP, and then the agent stuff on top of that, because there's some stuff going on around A2A, but also how that fits into Kubernetes context is quite interesting. Whether there's things we can leverage that exist already, or whether there's a brand new set of tools that get spawned out of that. I'm not too sure. I'm not an expert on the A2A stuff at the moment. But yeah, it'd be cool to see where that goes as well as part of this working group.
Yeah, makes sense.
Is there any other comments or topics? If not, I think we can end up the meeting and I give you your 5 minutes. This was a very valuable conversations, and thank you for all the insights, and see you next week. I think I should stop recording.